Here is another example where we need to determine whether the sequence converges or diverges, and if it converges, to find the limit. Our sequence is defined by the fraction 4 to the n divided by n plus 1 factorial. I want to go over this example because I want to give you an idea of the best way to work with factorials. And the best tip I can give you is to always write several factors out. Our nth term is 4 to the n divided by n plus 1 factorial. N plus 1 factorial means 1 times 2 times 3 times 4 times 5 times 6, and so on, all the way up to n, and then n plus 1. Now, if you count up on the bottom, we have n plus 1 factors. On the top, we have n factors of 4. So we have 4 times 4 times 4 times 4 times 4 times 4 times, and we continue on, 4. And I've suggestively lined these factors up with the first n factors in the denominator. We can kind of get a hunch about what's happening. If we look at this and we imagine n getting larger, after the first few pairs of factors, the factor that's on the bottom is always larger than the 4 that's on the top. If we compare 4 and 5, the bottom is larger. If we compare 4 and 6, the bottom is larger. The next factors would be 4 and 7, the bottom is larger. All the way up to 4 and n is larger. So we can come up with an inequality for these. We know that 4 over 5 is less than or equal to 1. We know that 4 over 6 is less than or equal to 1. And we know that each of the factors that are sort of contained in this dot, dot, dot is less than or equal to 1. And 4 over n is less than or equal to 1. And then just to simplify things, let's also point out that 4 over 4 is 1, so is also less than or equal to 1. That means that all in all, this fraction, this large fraction, is less than or equal to 4 times 4 times 4 on the top, and 1 times 2 times 3 times n plus 1 on the bottom. So I've kept the factors on the top and on the bottom that I haven't paired up into fractions that I know are less than or equal to 1. Putting this all together and simplifying, we get 32 divided by 3 times n plus 1. Notice that the expression 32 divided by 3n plus 1 is much simpler than the original expression with the factorial. So we can think about the limit as n approaches infinity of 32 divided by 3 times n plus 1. And because the denominator gets larger and larger as n approaches infinity, the fraction gets smaller and smaller and approaches 0. So we know that 4 to the n power divided by n plus 1 factorial is less than or equal to 32 divided by 3 times n plus 1. We also know that each term is greater than or equal to 0 because the limit as n approaches infinity of 0 is 0, and the limit as n approaches infinity of 32 divided by 3 times n plus 1 is 0. We can conclude by the squeeze theorem that the limit as n approaches infinity of 4 to the n power divided by n plus 1 factorial is also 0. So our sequence 4 to the n divided by n plus 1 factorial converges to 0.